All right, so this first problem says use rational zeros theorem to list all possible rational zeros of the following. So what this means is we're going to use P over Q. So P over Q, in this case, keep in mind that P would be 2. Q is then our leading coefficient, which is 3. So we're taking the factors of P over Q. So the factors of P would be plus or minus 1 and plus or minus 2. The factors of Q, which is 3 in this case, are plus or minus 1 and plus or minus 3. So ideally, to get the list of our factors, we just want to take the top divided by the bottom through each of these values to see what our numbers would be. So 1 divided by 1 would be 1, so plus or minus 1. 1 divided by 3 would be plus or minus 1/3. Then 2 divided by 1 would be 2. And then 2 divided by 3 would be 2/3. Keep in mind, as you do this and the problems get longer, you never want to repeat values. So if you end up with plus or minus 1 multiple times, you would only list it once. For the next problem, here we are given, it says find a polynomial of degree 3 with real coefficients and the following zeros. So in this case, they've given us 2 zeros so far. They've given us 2 and then 3 minus I, which means we also have the conjugate 3 plus I included. So the first step is let's just write this in essentially what's factored form. So it's going to be x minus, let's start with I'll start with the conjugate, 3 plus I. And I'm using brackets here. It's kind of like double parentheses because this is a big value or a lot to keep together in this place. So I'm just going to use brackets to help make it look nicer. And I've got x minus 3 minus I. So I can put this back into factored form. And then I've got x minus 2. So what I want to do first is I want to FOIL out this first part involving the conjugates. So first times first is x squared. Then we've got outer, and I'm going to leave this as kind of a setup problem. So x times negative quantity 3 minus I would be negative x times 3 minus I. I'll distribute that in the next step. And I've got the inside. Same thing here. Except 3 plus I. And then last, when you multiply conjugates, one of the things you should be aware of is in reality the middle of that value is not really going to do anything. It cancels out. So here we're really just going to take, well, the negative times negative on the outside is addition now. And then 3 times 3 is 9. And then positive I times negative I is negative I squared. If we were to FOIL out this quantity, like we would have to because it's kind of its own binomial, it would end up looking like this. I've just skipped a couple of steps here. So in this case, we can kind of clean this up. One of the ways we're going to clean it up is we're going to distribute this throughout the x's through both of these. So we've got x squared minus 3x plus ix, in this case minus 3x minus ix. Then we've got 9 minus, well, I squared is negative 1, so minus a negative 1 turns to add 1, so plus 10. We can still kind of clean this up one more time. So x squared, in this case minus 6x, so we've got the negative 3x, the ix's cancel, and then we've got plus 10. So right now we're back to a trinomial after all of this. But we still have to account for this. So we have to bring this down. The x minus 2 hasn't even entered the problem yet. So at this point, what we want to do is we want to distribute all of this trinomial through the binomial, or you can distribute the binomial through the trinomial. It's up to you. I think I'm going to distribute the x minus 2 throughout this trinomial. So I'm going to take x times x squared. I'm going to get x cubed. 6x times x is negative 6x squared. And then 10 times x is 10x. Then I'll distribute the negative 2 through, so negative 2x squared. Negative 2 times negative 6 is positive 12. Oh, this has an x on it, positive 12x. And then negative 2 times 10 is negative 20. So now I just want to simplify this. So I'm going to get x cubed. This becomes negative 8x squared. This is 22x. And this is negative 20. So in this case, f of x equals x cubed minus 8x squared plus 22x minus 20. So for the third problem, it says find all the zeros of p of x equals x cubed minus 5x squared plus 12x minus 8, given that 2 minus 2i is a 0. So this is an irrational 0, which means it's complex, which means we also have to account for the other form of this, the conjugate. So if this is one of our zeros, we automatically know that 2 plus 2i is also a 0. So we have one of our answers already. But because the degree is 3 here, we should have 3 total zeros. Right now, I only have 2 accounted for, which means I have to find the third 0 by putting this equation in our calculator on the y1 line. And then you can either look at your table, or you can look at the graph and use the 0 function. But you should find from your graph, or your calculator in this case, that your other 0 or your other root is at 1. So your other solution is 1. So right now we have 2 plus 2i, and then 1, and then 2 minus 2i make up our 3 solutions. So this is the answer to this problem. And then the fourth problem kind of brings together a lot of little things. So we got to kind of pick it apart here. So let's see. It says find another 0 of r of x. Well, they've given you 3 zeros right now. They've given you 1 real and 2 non-reals. What you can do to find one of your other solutions is to just take the conjugate of one of those complex solutions. So in this case, you could put 2i, or if you wanted to, you could take 4 plus I, the conjugates of these two. The next question says, what is the maximum number of real zeros that Rx can have? Well, in this case, it has a degree of 10, so that means there are 10 total roots or zeros between complex and reals that they bring together. So in this case, if you look at the problem, they've already given us 2 complex, which means we can account for technically 4 complex solutions so far. So 10 minus 4 means that the 6 remaining solutions could all be real. So this answer here is 6. Then for the last one, it says, what is the maximum number of non-real zeros? So this would be our complex or our imaginary and things like that. Well, in this case, they've only given us truly 1 real solution. So 10 minus 1 is 9. So that means the 9 other solutions are going to be some combination of complex and real. Well, it says, what is the max number of non-zero or non-real in this case? Well, remember, complex solutions have to come in pairs, so it has to be an even number. Well, the only even number, the largest even number that goes into 9, or that's less than 9, is 8. So this number has to be 8, because there's got to be at least 1 more real solution, and then the rest could be complex. So the answer there is 8.